Good day everyone. So here is chapter 2, Capacitors and Dielectric. So for this learning outcome, for learning outcome 2.1a, you have to define and use capacitance. Okay, so first of all, kita kenal dulu what is capacitor. Capacitor is a device or apparatus that is capable of storing electric charges or electric potential energy. It consists of two conducting plates separated by a small end cap or a thin insulator called dielectric. Okay. The conducting plate should be in the shape of cylindrical, spherical or parallel plate. And this is the symbol for capacitor. And dia berbeza dengan power supply. Power supply satu pendek, satu panjang, satu pendek. Positif, negatif. Ini power supply. And then capacitor bentuk macam ni. Okay, satu anode, satu cathode. Okay, ini adalah bentuk capacitor. Okay, so kita tengok what is capacitance. Capacitance, the symbol is C. The capacitance of a capacitor is defined as the ratio of the charge on either plate to the potential difference between them. Okay, so this is your Q over V. Q is the magnitude of the charge and V is the potential difference across the two plates. Okay, the potential of the C is a scalar quantity and the unit is farad or coulombs per volt. Okay, so soalan tanya, what is defined by 1 farad? Kita tahu 1 farad is equal to 1 coulomb per 1 volt. Kalau soalan tanya, what is meaning by 1 microfarad? So 1 microfarad is equal to 100. What is meaning by 100 microfarad? Okay, so 100 microfarad is ratio of 100 microcoulomb of charge per 1 volt. Kalau soalan tanya 1000 microfarad, so it will be 1000 microcoulomb per 1 volt. Okay, between the two plates. Okay, so here you have to derive and determine the effective capacitance of capacitor in series and parallel. Alright, so this is the capacitors in series. Okay, kalau nak perasan capacitors in series ni, kita ada kapasitor C1 dengan C2, misalnya kata kan, C1 dengan C2, kaki negatif ni jumpa dengan kaki positif. Berbeza dengan yang ni, kalau C1 dengan C2 ni, kaki positif jumpa dengan kaki positif. Itu antara beza antara series dengan parallel. Okay, beza antara series dengan parallel. Alright, so kita tengok lagi. When the circuit is complete, the electron transfer onto the plate such that the magnitude of the charge on each plate is same. Okay, so ingat kat sini, kalau series, dia punya Q is same. So Q total is equal to Q1 equal to QT, Q2 equal to Q3. Okay, the potential difference is different. Okay, so this is the formula to find the potential difference. Remember that the Q is same for the series. Okay, for the capacitor arranging in series. So kalau nak dapatkan V total equal to V1 plus dengan V2 plus dengan V3. And then to find the C effective for series, 1 over C effective equal to 1 over C1 plus dengan 1 over C2 plus 1 over C3. Okay, for the capacitors arranging in parallel, so kita nampak V di pula sama. Okay, tadi Q sama untuk series. Kalau V total yang kat sini, V1 equal to V2 equal to V3. Okay, and then ni punya charge pula yang kita kena tambah, Q1 plus dengan Q2 plus dengan Q3. Okay, and then dia punya C effective equal to C1 plus dengan C2 plus C3. Okay, so you have to remember all the formula for capacitors connected in series and capacitors connected in parallel. Okay. Okay, for learning outcome 2.1c, you have to derive and use energy stored in capacitor. Okay, when a switch is closed. Okay, so kat sini ada switch. Okay, switch close. Sebenarnya kalau tak macam ni lah. Okay, dia macam tu. Okay, ni switch off kan. Okay, kalau kita on kan switch ataupun switch close, the current will flow or the electron will flow in the circuit. Alright, and then a small amount of work is done in bringing a small amount of charge from the battery to the capacitor. That is given by dW equal to V dQ, and V is equal to Q over C. Alright, so when do the integration, you will have U, okay, U is equal to W equal to Q squared over 2C, or you can have U is equal to W equal to 1 over CV squared, ataupun U equal to W equal to half QV. Okay, so you can use all this equation, depends on the information given. Okay, and remember that the energy is scalar quantity and the unit is joules. Okay, we go to example number 1. Determine the effective capacitance of the configuration shown in figure. Okay, so before that, kita label dulu C1, C2, C3, C4, C5, C7, C6. Okay, so cakap all the capacitors are identical. Identical ni same value, and each has a capacitance of 2 microfarad. Alright, so kita combine kan yang ni dulu. Okay, combine C1, C2 and C3 which is connected in series. Ini sini sebab ni just ada junction saja. Okay, so 1 over C1, 2, 3 equal to 1 over C1 plus 1 over C2 plus 1 over C3. So 1 over C1, 2, 3 equal to 1 over 2 plus 1 over 2 plus 1 over 2. Okay, so 1 over C1, 2, 3 equal to 3 over 2 microfarad. Okay, so kita dapat C1, 2, 3 equal to 2 over 3 microfarad. Okay, so kita dapat dah C1, 2, 3. So kita lukis balik. Kita lukis balik kat sini akan jadi C1, 2, 3. Okay, this one is C4, this one is C5, C7, okay, this one is C6. Okay, so this one, okay, so yang ni sambung kepada power supply lah. Alright, so yang kedua, step number 2, kita dapatkan ini pula. Okay, this one is connected in parallel. Okay, in parallel, so bila parallel kita dapat C1, 2, 3, 4 equal to C1, 2, 3 plus C4. So C1, 2, 3, 4, C1, 2, 3 is 2.3 microfarad plus dengan 2. So kita dapat C1, 2, 3, 4 equal to 2.67 microfarad. Okay, itu step number 2. Nanti kita lukis balik. Okay, kita combine. Okay, kita combine C7, C5 kat ni akan jadi C1, 2, 3, 4. Okay, this one is C6. Okay, so bila combine, kita combinekan dulu this one. Okay, silap. Combinekan kita punya, this one is C5. Okay, kita combinekan ini. Okay, yang ni tak boleh combine lagi ya, sebab yang ni kita sambung kepada power supply. Okay, power supply positif dan negatif kita kata. Okay, so kita kita combinekan dulu C1, 2, 3, 4, C5 and C6 which is connected in series. Okay, so kalau connected in series, kita ada 1 over C1, 2, 3, 4, 5, 6 equal to 1 over C1, 2, 3, 4 plus 1 over C5 plus 1 over C6. Okay, so C1, 2, 3, 4, 5, 6 equal to 1 over 2.67 plus 1 over 2 plus 1 over 2. Okay, so C1, 2, 3, 4, 5, 6 equal to 0.727 microfarad. Okay, so the last one barulah kita combine semua. Okay, last one kita combine semua positif. Silap. Okay, kita ada C1, 2, 3, 4, 5, 6. Okay, C7. Okay, so disambung kepada power supply, positif, negatif. Okay, so ini adalah connected in parallel. Okay, C1, 2, 3. Okay, C1, 2, 3, 4, 5, 6 ni. Okay, C7 are connected in parallel. Kenapa parallel? Sebab kita nampak dia ada junction. Okay, dia ada junction. Okay, so bila connected in parallel, kita ada last kali kita ada C efektif ikut tu C efektif ikut tu C1 plus C1, 2, 3, 4, 5, 6 plus dengan C7. So C efektif akan jadi 2.727 microfarad. Okay, that's all. Okay, we go to example number 2. Example number 2. Okay, cakap apa? Cakap the figure in figure above C1 is C1 is 100 microfarad, C2 is 200 microfarad, C3 is 300 microfarad. The applied potential difference between A and B. Okay, so VAB equal to 8 volt. Calculate the charge on each capacitor. Okay, kita nak dapatkan charge on each capacitor. So sebelum kita nak dapatkan charge on each capacitor, kita kena cari dulu, kita kena kita kena make the circuit simple. Okay, so kita nampak kat sini C12, kita kena kita kena combinekan dia. Okay, C12. Alright, sebabnya kita nak dapat, kita tahu kita punya Q dekat sini. Okay, untuk kita dapatkan Q dia. Apa dia Q tu? Q tu adalah dia punya charge. Okay, so kita tahu C1 and C2 ni are connected in parallel. Okay, bila parallel apa yang sama? Bila parallel dia punya voltage 1 sama dengan voltage 2, tapi Q dia adalah Q total, iaitu Q1 tambah dengan Q2. Okay, so kita combine kan dulu untuk nampak dia lagi senang. Kita combine kan C1, 2, nanti kat sini kita ada C3. Okay, C12 macam mana dapat C12? Okay, C12 kita ada, okay, C12, okay, is connected in parallel. So bila parallel kita tambahkan lah. Okay, tambahkan C1 plus dengan C2. C1 is 100, C2 is 200. Okay, so C12 is 300 microfarad. Okay, so ini adalah 300 microfarad. So C3 pun adalah 300 microfarad. Okay, so dah settle kat situ. So then kita tahu pula dekat sini kita ada C12. Okay, C12 3 microfarad. Okay, so kita nak dapatkan Q. Okay, kita nak dapatkan Q supaya kita dapat tahu Q pada 1, 2 dengan Q3 adalah sama. Kenapa sama? Sebab dia adalah okay, Q12 sama dengan Q3. Kenapa? Because Q are connected in series. So bila series, okay, connected in series, So bila series Q sama, macam mana nak cari Q? Okay, so sebelum cari Q kita kena cari dulu, kita tahu Q sama dengan CV. So Q total, C total, V pun total lah. Q total, C kena cari C efektif. Macam mana nak cari C efektif? Okay, C efektif, C total tu sama Okay, we go to example number 2. The figure is as shown. So we have C1 100 microfarad, C2 200 microfarad, C3 is 300 microfarad. The applied potential difference is 8 volt. Calculate the charge on each capacitor. Okay, so kita nak dapatkan charge on Q1, Q2 and Q3. Okay, so sebelum kita dapatkan charge on Q1, Q2 and Q3, so we have to simplify the circuit first. Okay, we simplify the circuit. We have a C12 are arranged in parallel. Okay, so when arranged in parallel, kita simplifikan, we have C12. Okay, sebab kita nak dapatkan kita punya Q. Okay, Q is charge. Charge in series is same. Okay, so we have C12 arranged in parallel. Okay, so C12 we can calculate like this. C12 equals to C1 plus dengan C2. So C12 equal to 300 microfarad. Okay, C3 is 300 microfarad. Okay, so kalau kita simplifikan, kita nak apa? Kita nak buka kita punya circuit ni pun boleh. Okay, A and this one is B. So nampak kat sini C3. So kita dah nampak ini arrange in series. Okay, so when series, what is same? When series Q is same. Okay, Q is same. Alright, so we find the Q total first. So Q total equal to C effective darab dengan V total. Okay, we find the C effective first. Because C1, 2 and C3 arrange in parallel. Okay, arrange in parallel. Arrange in series. Okay, arrange in series. So the formula is 1 over C effective equal to 1 over C12 plus 1 over C3. So 1 over C effective equal to 1 over C12 is 300. 1 over 300. So your C effective is 150 microfarad. Okay, so Q total equal to 150 microfarad. V total given is 8. So Q total equal to 1200 microcoulomb. Okay, so kita dapat Q total 1200 microcoulomb. Okay, so for this one, okay, Q12 is 1200 microcoulomb. Q3 also 1200 microcoulomb, because the two the circuit arranged in series. Okay, so C3 kita dapat tadi, C3 is 300 microfarad. Okay, so daripada sini kita dah dapat, okay, kita boleh dapat V3. Okay, di mana Q equal to CV. So 3. So V3 equal to Q3 1200 over 300. So V3 equal to 4 volt. Okay, ingat, V3 equal to 4 volt. Okay, so V3 here is 4 volt. So kita tahu VAB is 8 volt. So V12 equal to 8 volt minus 4 volt is 4 volt. Okay, is 4 volt. Okay, so alright, kita dapat kat sini tadi 4 volt. V12 is 4 volt, and then we know that C1 and C2 are arranged in parallel, and then we know that V12 is 4 volt. Okay, so because arranged in parallel, so we know that V1 equal to V2 equal to 4 volt, because arranged in parallel. Okay, so we have here, okay, kita ada C1, C2. C1 is 200 microcoulomb. V1 is forward. C2 is 200 microfarad. V2 is forward. Okay, so from here we can get the Q. So we know that Q equal to CV. So Q equal to C is 200. V is 4. So Q2 equal to 800 microcoulomb. Okay, so Q2 800 microcoulomb. Q1 equal to C1 V1. So Q1 100. So Q1 is 400 microcoulomb. Okay, so kat sini charge on each capacitor. Q1 is 400 microcoulomb, Q2 800 microcoulomb. Di mana bila kita tambah Q1 and Q2, we have 1200 microcoulomb. Q3 is here 1200 microcoulomb. Okay. B, the potential difference across capacitor. Kita dah dapat dah tadi. V1 and V2 is 4 volt, and V3 is also 4 volt from here. The potential difference between point A and D. Okay, potential difference between point A and D. Okay, point A and D. So dekat sini lah pada V12. Okay, so this one is V12 is 4 volt. Okay, the energy stored, which is D, U equal to half CV squared. So U equal to half 150 times 10 power negative 6 V is 8 square. So U is 4.8 times 10 power negative 3 joules. Continue the example number 3. Figure shows a combination of 3 capacitors C1, C2 and C3. A 20 volt power supply is connected to the combination. Determine the effective capacitance in the circuit. Okay, so we have C1, C2 and C3. So we know that C2 and C3 are connected in series. Okay, so to find the capacitors connected in series, we have C23 equal to 1 over C2 plus 1 over C3. So 1 over C23 equal to 1 over C2 is 22 plus 1 C3 is 1 over 47. So C23 is equal to 15 microfarad. Okay, so the circuit will be like this. We have C1 and then we have C23. This is 20 volt. Okay, so then we calculate the C effective. C effective because C1 and C3 are connected in parallel, so we have C1 plus dengan C23. So C effective equal to C1 is 100 plus dengan C23 is 15. So C effective will be 115 microfarad. Okay, we go to number B. The charge stored in C1. Okay, charge stored. So the charge stored in C1. So kita tahu Q1 equal to C1 V1. So Q1 C1 already have 1000 microfarad. V1. Okay, so we know that V1 is also 20 volt. Okay, V1 is 20 volt. Okay, so 20. So Q1 equal to 2000 microcoulomb. Okay, alright. So kita nak dapatkan pula potential difference across C2. So macam mana dapatkan potential difference across C2? So kita dapatkan dulu dia punya Q total. Okay, kita dapatkan dulu dia punya Q total. So Q is equal to C effective dalam V. So Q C effective is 115 microfarad. V is 20. So Q will be 300 microcoulomb. Okay, ini adalah total charge yang ada dalam kita punya circuit. Okay, total charge yang ada dalam kita punya circuit. So kita dah dapat tadi Q total equal to Q1 plus dengan Q23. Okay, Q23. Kenapa I buat Q23? Because Q2 sama dengan Q3 because Q23 are connected in series. Okay, so Q total is 2300. Q1 we already have 2000 plus dengan Q23. So Q23 equal to 300 microcoulomb. Okay, so kita nak dapatkan tadi apa? Potential difference. So potential difference kita ada Q equal to CV, Q2 C2 V2. So V2 equal to Q2 over C2. So V2, this one Q2 equal to Q3 juga ya, because the Q23 connected in series. Okay, so 300 C2 is C2 berapa tadi? C2 is 22. So V2 is equal to 13.64 volt. Okay, 13.64 potential difference across C2. So kalau kita nak dapatkan potential difference across C3 pun boleh. Okay, so kita tahu untuk V23 adalah V2 plus dengan V3. Okay, V23 ini adalah 20 volt. Okay, V2 kita dah ada, V2 is 13.64. So to find V3 kita ada 20 minus 13.64. So V3 is equal to 20 minus 6.36 volt. Ini adalah kita punya V3. Alright, so the other one, calculate the energy stored. Okay, so U3 equal to, boleh guna Q square over 2C, ataupun boleh guna half CV square ataupun apa-apa yang berkaitan lah. So U3 equal to Q3 square over 2. Okay, Q3 is 300 times 10 power of negative 6 square over 2. C3 is C3 is 47 times 10 power of negative 6. So U3 equal to 9.58 times 10 power of negative 4 joules. Okay, so this one.